Right, we now are going to consider the motion of an object. I'm calling it projectile motion because it's an object we're going to throw up into the air and let it fall back down again to its original position. Something like that. We're going to ignore any sideways motion of the object. And so that little path sort of traces out the movement that the object has made. We're going to, for the purposes of this discussion, we are going to ignore friction. Now let's say we threw the object up with an initial velocity of 50 meters per second. So here I've put some numbers in, 50 meters per second. Let's, for the argument's sake, here assume that gravity is 10 and not 9.8. If that's the case, then a second later the object would have lost 10 meters per second, so it would be going at 40 meters per second. Another second later it would be going at 30 meters per second, and so on. Every second as it moves up, it would lose around 10 meters per second. And so eventually after 5 seconds it would be doing 0 meters per second. It would stop moving up. Still under the same force of gravity, so now it would accelerate at the same rate that it was losing velocity on the way up. So now it gains 10 meters per second in the negative direction. So its velocity is minus 10. In the next second it gains another 10 meters per second. So its velocity is minus 20, etc., until it comes down just before it hits the ground from which it was thrown, or the point from which it was thrown. It's now got a velocity, downwards velocity minus, of 50 meters per second. Right? That is with a constant 10 meters per second acceleration. It's a deceleration going up, acceleration going down. If you were now going to look at the acceleration graph, you would see in the first second it lost 10 meters per second, and so its acceleration would be 10 meters per second squared. Every second as it's going up, it loses 10 meters per second. It goes from 50 to 40 to 30 to 20. And so its acceleration is negative 10 meters per second, because it is losing 10 meters per second every second, 10 meters per second. Once it gets to the top, it's still now under the same force, so it begins to accelerate. So its acceleration is minus 10 the whole time. Over there it loses 10, over here it gains negative 10. So its acceleration now is still minus 10 meters per second per second. It's gaining a negative 10 meters per second every second. Now if you put those values into a table, your velocity would go from plus 50 down by 10 every second to minus 50. Your acceleration would be minus 10 for the entire journey. Even when the velocity is 0, the acceleration would still be minus 10. Because the second before it loses 10, and the second afterwards it gains minus 10. So the acceleration stays the same the whole time. So we're going to talk about projectile motion. We're going to talk about an object, whether it's been thrown up and falls down, or whether it's just dropped, like this one is. For the whole time it's in free fall is the time that it's only under the action of gravity. Its acceleration will be 9.8 meters per second squared. Now you may remember these old equations from grade 10, the equations of motion, and 3 of them have got acceleration in them. But if you apply them for vertical motion, then you can change the value of A to the value for G, because the acceleration of any object under the action of gravity only will have an acceleration of 9.8 meters per second squared downwards. So it normally is put in as negative. So we define free fall. What do we mean by free fall? That's if an object is moving up or down with no other influence on it except gravity. We'll ignore air friction in most of the examples, and therefore you can substitute G for A in any of these equations. Right, just a couple of tips before we do calculation. Here we have an object, it's thrown up and it falls back down. Now we're going to ignore the sideways motion. Let's just think about it a bit. If we take up as positive, then since it's only under the force of gravity, if we throw it up with a positive velocity, if we take up as positive, its acceleration is still minus 9.8 meters per second squared. At the top, at the apex, its velocity will be momentarily 0, but the acceleration is still minus 9.8 meters per second squared. And when it gets down to the bottom here, its velocity is now negative. It'll be the same value as it was, and the acceleration is still minus 9.8. So the only force on the object is its weight. Accelerates downwards continually. We're calling downwards negative. Momentarily 0. and the time going up should be equal to the time going down. And obviously the velocity at the start is equal to the velocity at return, just before it hits the ground. Obviously once it hit the ground, its velocity would be 0, but when we say the final velocity, we're talking about the velocity just before it hits the ground. Alright, now we can move on to